Hi, Lena here. Welcome. In today's video I will be sharing information with you about what scientists believe about different realities due to the quantum theory. Stay tuned. Can two versions of reality exist at the same time? Physicists say they can at the quantum level, that is. Researchers recently conducted experiments to answer a decades-old theoretical physics question about dueling realities. This tricky thought experiment proposed that two individuals observing the same photon could arrive at different conclusions about that photon's state, and yet both of their observations would be correct. For the first time, scientists have replicated conditions described in the thought experiment. This perplexing idea was the brainchild of Eugene Wigner, winner of the Nobel Prize for Physics in 1963. In 1961, Wigner had introduced a thought experiment that became known as Wigner's friend. It begins with a photon, a particle of light. When an observer in an isolated laboratory measures the photon, they find that the particle's polarization, the axis on which it spins, is either vertical or horizontal. Before the photon is measured, the photon displays both polarizations at once. As dictated by the laws of quantum mechanics, it exists in a superposition of two possible states. For decades, Wigner's mind-bending proposal was just an interesting thought experiment. But in recent years, important advances in physics finally enabled experts to put Wigner's proposal to the test, Ringbauer said. Scientists tested Wigner's original idea with an even more rigorous experiment which doubled the scenario. They designated two laboratories where the experiments would take place and introduced two pairs of entangled photons, meaning that their fates were linked, so that knowing the state of one automatically tells you the state of the other. The authors of the new study found that even in their doubled scenario, the results described by Wigner held. Alice and Bob could arrive at conclusions about the photons that were correct and provable, and that yet still differed from their observations, which were also correct and provable, according to the study. It seems that, in contrast to classical physics, measurement results cannot be considered absolute truth but must be understood relative to the observer who performed the measurement. This is a very interesting case of science and seems very plausible. I would have to believe that different realities are definitely real. But why does this occur is a question I have. Well, so long Earthlings, thank you for watching. Don't forget to like and subscribe. Follow me on Instagram at Lena Hologram. See you next time. For more information about the quantum world and reality, I'd advise reading this awesome book, Quantum Reality: Beyond the New Physics by Nick Herbert. Provided the link down below.